Assalamualaikum and hi. My name is Muhammad Danish Arma Ariel bin Armanizam. My metric number is AA241720. And today I would like to introduce our project in the background and our problem statement. So the background itself, the most office workers spend many hours sitting while using a computer. So traditional fixed height desks are forced the users to remain in one position, which can lead to discomfort and poor posture. And adjustable height work desk would solve this problem by allowing the users to easily switch between sitting and standing itself. So next one we'll continue to the problem statement where the fixed height desks are not suitable for everyone because some people have different body heights. This can cause neck, shoulders, and back and wrist pain over and over time. This problem may develop into musculoskeletal disorder. So therefore, the improvement of the desk design is important to provide a better ergonomics, comfort, and also overall health for office workers.
Hi, my name is Muhammad Danish Hakim Imad Hadid. Matrix number AA241479 will be presenting the problem statements and the comparison of the project design, evaluation, and improvement. So we'll move on to the problem statement first, and these are the problems that we have to solve when we're making this in mechanical industrial desks. So the first one is the ergonomic issues in current industrial desks, which is the musculoskeletal disorders or chronic musculoskeletal disorders from static postures, which is which did prolonged sitting on traditional fixed height desk locks on the operator into rigid static postures, restricting localized blood flow and causing chronic neck, shoulder, and back inflammation. And the next one is the extractive bending moments on lumbar spine. This is a critical situation for ones who using the industrial desk, which is standard static workforce operators to lean forward constantly, shifting upper body weight away from the vertical axis. And this exerts a massive bending moment and compresses intervertebral disc. Next, we move on. Next, we look onto the workstation mechanical flaws, and the first one is rigid 73 centimeter fixed height, which impose a severe mismatch for tall and short users, resulting in extreme neck flexion and static shoulder elevation. So this is not good for everyone with flexible height. The second one is straight edge platforms provide zero dynamic forearm support, leading to localized contact stress and ulnar or median nerve compression. And the last one is lower frame obstructions. Permanent structure bracing bars severely restrict knee clearance and leg room, forcing unhealthy twisted lower body postures.
The methodology was conducted to evaluate the ergonomic limitation of a conventional industrial desk and develop an industrial desk with adjustable height that improves user comfort, posture, and productivity. The study of workplace and equipment selection, observation and data collection, literature review, ergonomic assessment using REBA, purpose design improvement. For the workplace and equipment selection, the selected workplace is an industrial workstation where workers perform computer-based tasks, documentation, inspection, and monitoring activities for extended periods. The existing problems: fixed desk height cannot accommodate different user heights. Workers often adopt a quad sitting posture. Poor workstation ergonomics may lead to neck, shoulder, wrist, and lower back discomfort. And long working hours increase the risk of musculoskeletal disorders, MSD. For the data collection method, observation method, observe workers performing daily workstation activities, record body posture during typing, monitoring, and documentation tasks, capture photographs for ergonomic posture analysis. The literature review, references from journals and ergonomic standards were reviewed to support the project, including ergonomic workstation design, adjustable desk system, anthropometric measurements, and musculoskeletal disorders.
Next, we move on to the primary objective of the proposed design improvement. The first one is ergonomic analysis, quantify structural ergonomic risk of standard fixed height desks using standardized RIBA postural evaluation tools. Second one is dynamic height adjustment, redesign leg structures to support 620 and 1250 millimeters height adjustment to ensure constant neutral spine alignment. Third one is anti-collision loop, engineering a fail-safe sensor control system that instantly posterable to eliminate crushing hazards. And the last one is curve platform, design a contour butterfly surface curve to reduce upper limb ridge strain and support the forearms.
For proposed design improvement, adjustable height mechanism suitable for both sitting and standing position, stable steel frame construction, smooth height adjustment system, larger and more organized working surface. The expected benefits: improve working posture, reduce neck, shoulder, wrist, and back strain, lower the of musculoskeletal disorders, increase user comfort and productivity, suitable for user with different anthropometric measurements.
Next, we move on to the comparison and improvement under proposed design improvement. So the first one is leg profile architecture, and the current one is single segment and continuous 75mm times 75mm steel HSS tube welded directly into the top frame. And the improved one that we did is double segmented telescoping nested SHS profile, converted a fixed vertical support into a variable height column with a straight 150mm safety overlap to resist side loading forces. And the next one is joint interaction. And the current industrial desk is rigid and non-moving connection secured via full penetration structural MIG welds. And the improvement is linear sliding interface guided by external heavy-duty roller bearings. We replace high friction metal on metal sliding with low resistant roller contact to eliminate column binding and station. And the third one is actuation and force profile. And currently, the industrial desk using purely manual frame relies entirely on the operator to lift or move tools. And the improved one that we did is dual 24-volt DC high torque gear motors coupled to trapezoidal ACM elite screws. Replace physical operator strain with automated synchronized mechanical advantage capable of dynamically lifting a 100 kg payload. And the next one is the locking and stability system. And the current industrial desk use permanent structural rigidity maintained by welded steel corner gussets. And the improved one is self-locking thread geometry paired with fixed bronze flange nuts. Eliminated the need for manual pins or locks. The steep thread pitch angle prevents gravity back driving under full load. And the last one in the comparison and improvement is the control and leveling system. And currently, the industrial desk use none of the leveling system, and desk relies on adjustable floor leveling feet for minor initial setup. And the improved one, we use microcontroller linked loose closed loop rotary encoders with an H-bridge power window motor driver. Replace a completely manual baseline with real-time electronic speed matching, maintaining a level workspace within ±2 millimeters.
My name is Muhammad Ashraf bin Muhammad Akbar. My matrix number is AA240040. I'm going to present the discussion part of the redesign evaluation. So we will go to the first point, which is the ergonomics and reach optimization. So the first point is height adjustment range. It features dynamic vertical travel within 620mm to 1250mm to fit users from the 5th percentile sitting to the 95th percentile standing. So the second is ergonomic design. Okay, A curved butterfly in the edge is base essential item in the primary ridge zone. Okay, it is to reduce shoulder strain. The second point is active electromechanical sync. So the first point of this point is leveling precision. It uses a closed loop system with high resolution rotary encoders and Arduino pulse width modulation control to match the CG motor speed, keeping the dash level within more than or less than 2 mm. So the safety feature is it is built with self-locking Acme threads and dynamic anti-collision feedback loops to ensure safe operation. Okay, the third point is the manufacturing and structural feasibility. So the first is robust fabrication. Constructed with square steel, tubing and nest inner tubes. The second is load capacity. Maintains a 150 mm structural overlap constraint to prevent column bulking under loads up to 100 kg. So the maintenance is highly cost effective and easy to maintain. So 45% increase. It increase in administration productivity. So the transition from a fixed desk to a motorized seat stand configuration significantly lowers occupational fatigue and the amount of lift and boosts overall work rate. Okay, thank you.
So last one we will continue in the conclusion of our project where the adjustable height headboard desk is designed to overcome the limitation of the traditional fixed height desk by allowing the users to easily switch between the sitting and standing position of themselves. So it's motorized the height and adjustment between 62 to 125 centimeter, an ergonomic butterfly shape and desktop and be- beveled front edge where improve the posture and reduce strain on the neck, shoulders, back, and wrist, and it also provide a greater comfort during a long working hours. So the desk also includes an anti-collision safety sensor which want to ensure the safety operations and overall of this design. This promotes better ergonomics and reduce risk of musculoskeletal disorders MSD, and improve workplace comfort, health, and also its productivity itself.